Today we discuss about open sets related problems. Okay, first problem we discuss a set U subset of X of a matrix space is open if and only if their union it is the union of open balls. Okay, we prove it. We write the in question from a set U subset of X of a matrix space of a matrix space is open if and only if it is the union of open ball. It is the union of open balls. Okay, now we prove it. How we prove it? We prove it so simple way. For x belongs to u, you let rx greater than 0, let rx greater than 0 be such that bx rx subset of u, okay. Then u equal to union of x belongs to u rx, bx rx. Okay, that means if we check about that, we check about any radius rx greater than 0 for x belongs to u x is open, so there exists a neighborhood of x, that means bx rx open wall about x of rx radius subset of u, then u equal to union of x belongs to u, b of x rx. Okay, in simple way, if it is the union, that means one u is the union of x belongs to u ball of x rx, then what we obtain? There exists x such that x belongs to bx rx, and this bx rx subset of u, so u subset of x be open also. Okay, now discuss further one. We will erase this portion, that means open set related topic we discuss now we erase this portion. So what we learn for this problem, from this problem what we learn? U subset of x of a matrix space is open if and only if it is the union of open balls. That means some open set of a matrix space is the union of open balls. Okay, next we start about another problem. If x norm is a norm linear space, and u is open in x, then x plus u is open, open for any x belongs to x. Okay, so how we prove it? We prove it so simple way. Let y belongs to x plus u, then y belongs to x plus u means this implies that then y equal to x plus p where p belongs to u. Okay, for some p belongs to u, let r greater than 0 be such that BPR, one ball whose center is P and radius is R, subset of U. Okay, then BYR, open ball, subset of X plus U. Understand? That means we take some r greater than 0. We such that BP, center P and radius R, subset of U. Then BYR, subset of X plus U. Then X plus U be open. Then X plus U be open for any X belongs to X. For any X belongs to X. Now we discuss further another questions, similar question, just we write here also. If X norm be a non-linear space and U is open in X, then A plus U, then just one, this one is an element, this one is a set. A plus U for any A subset of X. Okay, for any A subset of X, this one happen. Okay, then how we prove it? Then we prove it if A equal to phi, this one is common. We erase this portion and we start this now. If A equal to phi, then A plus U, obviously phi plus U equal to U. Okay, then open in X. Now if A not equal to phi, then we have to show that A plus U equal to union of A belongs to A such that A plus U. Okay, that means all A belongings to A such that A plus U union equal to A. And we by previous questions we know about that A plus U is open. So and arbitrary union of open set is open, and arbitrary by previous questions, and arbitrary union of open set is open, then A plus U be open. Okay, so we done this problem also. Next we show one important example or one important questions. One important questions that is related to open set. Let X norm be a norm linear space. Let X norm be a norm linear space. X norm be a norm linear space, and if any vector subspace Y of X is open, if any vector subspace Y of X is open, then Y equal to X. Similar we prove in for set, if any subset is open. Similar we prove if G be an open subset of R, is also a subgroup of the group R plus, then G equal to R. And here also X norm be a non-linear space if any vector subspace Y of X is open, then Y equal to X. Okay, so how we prove it? We prove it simple way. Observe that in beta 0 R, that means B0 in R. Okay, and union of B0 in R equal to X. Now we discuss about that. That means how we prove it. Okay, at first we see that at Y be open. Y be open means let Y also vector subspace, that means Y subset of X given, and now let X belongs to X, then if X is open and Y is open here given, X non-linear space and Y open, then X belongs to union of B0 in R, and since X is the union of some open walls. Okay, now then we find that X belongs to any enough for some n belongs to J plus, and here for any n. Okay, then we see that this X belongs to n B0R for any n, and Y also open, then X belongs to Y also, because B0R contained in Y, B0R contained in Y, then NB0R obviously contained in Y, and this one equal to, this implies that X subset of Y, and then Y equal to X. If X belongs to B0 in R, or some n belongs to Z, then X belongs to, for any n belongs to this one happen, and this implies X belongs to n B0R. This implies that X belongs to Y, since Y is open. Y open, so B0R subset of Y, then X belongs to this one. Okay, this implies that means NB0R equal to B0 in R. Okay, and union of B0 in R equal to X. So we see about that y equal to x. Okay, in any norm linear space, if any vector subspace is open, then y equal to x. In this way we done also. Now then now we proceed further. Can you generalize this problem? That means if any vector subspace y of x open, then y equal to x. Can you generalize this problem? If if a translate a plus y of a vector space y is open, then a equal to x. If a translate a plus y of a vector space y is open, then a equal to x. A translate a plus y of a vector space y is open, then a equal to x. That means if y equal to b0 are subset of x, then n b0 are equal to b0 n r, and obviously union of n belongs to n b0 n r equal to x. So we see about that a plus y, a translate of y is denoted by a is denoted by a plus y. A translate of y is open. If open, then obviously a equal to x, then this equal to x. Previously we also see that translate is open, then a plus u is open, then obviously if a vector subspace open, then this one equal to same norm space. Now we see about that one important problem, which problem is in question form: C01 is not an open subset of B01. C01 norm is not an open subset of B01 norm infinity. Okay, then 12.15.1.2.15.2 is say about that if C01 is open in B01 then it is an open vector subspace. Then it is an open vector subspace. It is an open vector subspace, and hence we must have C01 equal to B01. But every bounded function, that means every bounded function is continuous. That means every bounded function on 0 1 is continuous. This one an absurdity or contradict. So C01 is not an open subset of B01. Okay, so today's stop here.